Okay, so we're on unit 3.2.
Are we gonna like
3.2 is going to be simplify exponents. Now, this is something that I'm actually doing with my 8th grade class right now, so I am for sure that you guys have seen all of these properties of exponents before. You may not remember them, which is why today is going to be kind of a review day. But you do need to know that I would like you to leave answers in exponential form. Leave answers in exponential form without negative or zero exponents. So leave answers in exponential form without negative or zero exponents. So no negative exponents, no zero exponents. So to start with, for example number 1, I would like you to simplify 7 to the 4th times 7 squared. 7 to the 4th times 7 squared. There's a rule here that tells you when you are going to multiply with the same base. Okay, if you were going to multiply with the same base, and the base would be the 7 here. If you're going to multiply with the same base, does anyone know what the rule is about their exponents? First off, what do I do with the bases? What do you think I do with the 7 and the 7? Any ideas? You actually need to keep the same base. Keep the base the same, so you are not multiplying the 7 and the 7. And does anyone remember what do you do with our exponents? Add their exponents. Okay, keep the base the same, add the exponents. Now, that's a little bit different than if I give you something like this. For number 2, if I ask you to do 7 to the 4th to the 2nd power. 7 to the 4th raised to the 2nd power. The rule that you need to remember here, if it's power to a power, okay, if you're going to do a power to a power, anyone know what happens to the base? What do you think we do with the base? I wrote it down. It says keep base. What do you think I do with the exponents? Multiply the exponents. So keep the base and multiply the exponents. So what would be 7 to the 4th raised to the 2nd power? Multiply the exponents, so 4 times 2 is 8. Okay, so 7 to the 8th power. Oh, we didn't actually finish number 1, I'm sorry. Sorry, number 1, what should have been my actual answer? If you add to the exponents, it should be 7 to the 6th power. I apologize, I didn't actually finish. There you go. So, key thing here to remember is what's the difference between when do you add them, when you multiply them. The way that I tell my 8th graders to remember this, and it may help you, if it doesn't help you, then it's not, super important. But the way I tell the 8th graders to remember this is if you have power to a power, so they're right next to each other, all that can fit in between them is just a little tiny multiply dot. Okay? But if you have exponents that are farther apart, you can fit a big plus sign in between. That's the way you remember which ones multiply and which ones add. Has nothing to do with math. It's just a small little thing that may help you remember the difference. Okay, so there's big space. You can fit a big plus sign in there. If there's just a little space, just a little multiply dot can fit in there, and that's it. Okay, let's try another one. How about, for example, number 3? For number 3, I would like you to do 6 to the negative 2 power raised to the 5th power. 6 to the negative 2 power raised to the 5th power. So, first thing you want to do is distribute your exponent. So we're going to take the 5 and it goes to this negative 2. the 5 does not multiply with the 6. Okay, so here, the first step here is this will become 6 to the what power? Am I going to add these or multiply them? Multiply, so 6 to the negative 10 power. Now, there's a rule about negative exponents. Okay, anytime you have a negative exponent, you want to move negative exponents to opposite side, to the opposite side of the fraction to become positive exponents. Okay, move negative exponent to opposite side of the fraction to become positive exponents. So here is 6 to the negative 10th power. Is that written as a fraction currently? No, but can I write it as a fraction? How do I make it into a fraction? How do you make anything into a fraction? Just put a 1 underneath it. So make it a fraction. Just put a bar, put a 1 underneath it. Then all you have to do is anytime you have a negative exponent, you're literally just going to switch its side. So move it to the opposite side. So this moves to the denominator of the fraction bar. And it will change its exponent. Okay, its exponent will change to be the opposite sign. So to get a negative exponent, you move it down, it becomes positive. Now, don't forget that you have to leave something in the numerator. So there is actually a 1 left behind there. Okay, you have to leave that placeholder 1. You can't just all of a sudden make it a positive 10 in the top. Okay, you do have to move it to the bottom. That's your answer. So 1 over 6 to the 10th power. Questions on how I did that? You guys have seen this before, right? I think. Hopefully. Okay, you might be a little rusty on it. You might not remember it. But hopefully it'll come back to you. For number 4, let's multiply 2 to the 4th times 2 to the 0 power times 2 to the negative 11th power. 2 to the 4th times 2 to the 0 times 2 to the negative 11th power. Okay, you should also know a rule about anything to the 0 power. Okay, anything to the 0 power equals what? Does anyone know? Anything to the 0 power equals what?
0.
Equals 1. Okay, anything to the 0 power equals 1. Not times 0, but anything to the 0 power equals 1. So literally, this one just goes away. It doesn't become 2 to the 1st power. It just becomes 2 to the 4th times 1 times 2 to the negative 11th. So really, it basically just disappears because you're just going to multiply by a 1. So then if you're multiplying these two together, what do you do with their exponents? Add them or multiply them? Add them. So 4 minus 11 gives you negative 7. And then how do I write that with a positive power? Make it a fraction. Flip it to the bottom. And then, yes, this would become 1 over 2 to the positive 7 power. Yes. No, if they're next to each other and they have the same base, you add them. If it's power to a power, you would multiply them. Okay, so power to a power, if the exponents are right close together, you multiply them. If they're kind of spread apart, that's when you add them. Okay, so this would be 1 over 2 to the 7th power. Now, those are the fundamental properties of exponents, okay? Now we're going to move on to the questions that are going to be a little closer to like what your homework looks like. Okay, so these are just the fundamentals. This is what you should already pretty much be pretty decent at doing. Okay, now we're going to go on to ones that are going to be a little bit closer to what you're actually going to do in homework. 3x to the negative 1 over y to the negative 2. 3x to the negative 1 divided by y to the negative 2 power. So for this one, anytime you have a negative exponent, you're going to move whatever's attached to the negative exponent to the opposite side of the fraction bar. Oh, and I'm sorry, this should be a negative 3. Negative 3x to the negative 1 over y to the negative 2. So here, what actually needs to move? I definitely need to move the x to the negative 1 down to the bottom. The y to the negative 2 definitely moves to the top. What about the negative 3? Does that need to move? That does not need to move, okay? We only move things that are attached to negative exponents. Negative numbers are perfectly fine, okay? Negative exponents have to move. So here, negative 3 stays on the top. The y to the second comes to the top and it becomes positive over x. Now, technically you could write x to the first, but we don't have to, okay? X is just a fine answer. Okay, if you write x to the first, that's fine, but you don't have to. Okay, so I want you to kind of write yourself a note along with this. And keep in mind that negative exponents make fractions. Okay, negative exponents make fractions, not negative numbers. Okay, that's a really big misconception. A lot of people try to make negative exponents equal negative numbers. That does not happen. Negative exponents just make fractions. They do not make the whole thing negative. Okay, let's try another one for number 6. A couple more. Number 6, quantity, so that means in parentheses, 3a cubed raised to the negative 2 power over a to the negative 3, b to the negative 3. Quantity, so in parentheses, 3a to the third raised to the negative 2 power divided by a to the negative third over b to the negative third. Anyone think they know where would you start on this problem? Any ideas? Isaac? Perfect. Okay, so distribute the negative exponent. So this negative 2 actually belongs to the 3 and the a. Okay, if it's in parentheses, it goes to every single part. So if you distribute that, you would have 3 to the negative 2, a to the what power? What do I do with these powers? Do they multiply or add? Multiply, so a to the negative 6 over a to the negative 3, b to the negative 3. Now, before you do anything, okay, before you reduce any of these a's, you do need to move all the negative exponents. So basically, everything is going to switch sides here, okay? The 3 moves, the a moves, this a moves, that b moves. So everything, we're just going to flip it upside down, and basically it's going to turn all positive. So in the top is now going to be a cubed, b cubed. In the denominator is 3 squared, a to the 6th power. It's not negative 3, okay? Just the exponent changes to become positive. Then we can actually reduce. The b's are going to stay in the top because there's nothing else there. What do you do with these a's? A to the third is technically a times a times a, so there's 3 of them. If there's 3 on the top, 6 on the bottom, where will it win? Do they stay on the top or the bottom? The bottom. And how much does it win by? How many more are on the bottom? 3. And then what happens with 3 squared? Can you simplify 3 squared? I hope so. What is 3 squared? 9. It's not 6, not 3 times 2, but 3 times 3 is 9. So if it's something like just to the 2nd power, you should definitely be able to simplify that. Okay, you don't need to leave that with exponent form, and that's your answer. Okay, so b cubed over 9a cubed. Any questions on how I did that? Not too bad. I've got 2 more, and then we'll be done. Number 7. Okay, number 7. I would like you to simplify x squared over y raised to the negative 1 power multiplied by x over y cubed squared. So x squared over y to the negative 1 power multiplied by x over y cubed squared. So make sure you look really closely, because a lot of times it's really easy to kind of mix up those numbers. So just like the last problem, first thing you want to do is distribute your exponent. Now, anytime you have a fraction and it's in parentheses, this exponent belongs to the top and the bottom. Okay, so you do have to distribute it to the numerator and the denominator. Then if you simplify this, that's going to give you x to the, what do I do with the 2 and the negative 1? Do I add them or multiply them? Multiply, so x to the negative 2 over y to the negative 1 multiplied, or I'm just going to put a multiply dot. You could leave it in parentheses, but you don't have to. x squared over y to the what power? 6, because they multiply. Then, since I have these next to each other, what do I do with them? Do I add their exponents or multiply them? This is an add problem. So what's x to the negative 2 multiplied by x squared? What do I do with our exponents? What happens? They go away, so it becomes x to the 0, which is really 1. So 1 happens in the numerator. So basically the numerator, these negative 2 exponents cancel out those positive 2 x's. Okay? Then in the denominator, y to the negative 1 times y to the 6 becomes y to the what power? 5th power. Okay, so your actual answer here is 1 over y to the 5th. Do you have questions, Tyler? No. Okay, one more and then we'll be done. Okay, last one. For number 8, I would like you to simplify r to the negative 1 over s to the negative 2 multiplied by r to the negative 1 over s to the second, s squared, raised to the negative 1 power. R to the negative 1 over s to the negative 2 multiplied by r to the negative 1 over s to the positive 2 raised to the negative 1 power. So, what do you think we do first? Should I do the exponents first or should I multiply first? Which one comes first in order of operations? Exponents. So you do have to distribute the exponents first. So this negative 1 goes to the numerator and the denominator. So just rewrite this first fraction. So r to the negative 1 over s to the negative 2 multiplied by what happens with these negative 1s? Do they multiply or do they add? Multiply. So r to the positive 1 over s to the negative 2. Now, you could do this one of two ways. Okay, you could combine them first, or you can move all the negatives first. Does not matter. I'm going to choose to combine them first because it's a little bit easier. So r to the negative 1 times r to the positive 1 gives us what? Just a 1. It goes away. Okay, this becomes basically r to the 0 power, which is just 1, over s to the what power? Negative 4. And then remember, I don't want any answers with negative exponents. So here, this one's actually going to move from the bottom to the top to becomes positive. So x to the 4th. You do not need to write it over 1, though. That's your answer. Okay, just s to the 4th. Anybody have questions? Yes.
Can you, since there's r is negative 1 and s negative 2, can you switch those positive there?
You could. If you did the other way, you would flip these. So you'd got s to the 2nd over r to the 1st. Then in this one, when you switch them, you'd also get s to the 2nd, and you'd still have an r. So either way, these could rewrite, and you'd get s to the 4th r over r. Then these would reduce each other away, and you'd still end up with just s to the 4th. So a lot of these problems are a little frustrating sometimes because there's multiple different ways that you can arrive at the right answer. Okay, like you don't have to do this part first. You could flip them and still get the right answer. Okay, so either way is totally fine. Homework for this is going to be worksheet